This is homework set 22, solving radical equations. Question 1, we have this radical equation here. Square root of 5x plus 1 is equal to 4. So what values of x can we put in here, multiply by 5 and add 1, take the square root and get 4. So let's solve it for x. Now that x is under that square root, so let's square both sides. Now here's how I write it. I write the quantity 5x plus 1 square root squared equals 4 squared. So I'm just going to take square this, so square both sides. And on the left side, when you square square root, the radical comes off. You get 5x plus 1 is equal to 16. All right, subtract. So 5x is equal to 15. X is equal to 3. But I know when I square both sides or raise both sides of an equation to an even power, I have to check. So let's check this. And I like to check like this. I'll say if x equals 3, then, all right, so put that 3 back into the original. So I'll get the square root of 5 times 3 plus 1. Now, is that equal to 4? Well, this will be the square root of, all right, just do this. 15 plus 1 is 16. Oh. Is that equal to 4? And sure enough, 4 equals 4. It checks. So now I will conclude that x is equal to 3. Question 2 asks us to solve each one of these equations for x. All right, let's start with the first one. So I'll start with this one right here. Square root of 3x plus 1 equals 4. So let's square both sides. So I'll get the square of the square root of 3x plus 1 squared equals 4 squared. So when you square a square on the left side, we'll get the 3x plus 1. When you square a square, the radical comes off, equals 16. Subtract. 3x equals 15. X equals 5. All right, now let's check this. We absolutely have to check. This is a potential solution. So take this 5 and put it back into the original. All right, so it'll look like this. I'm going to say this. Check. If x equals 5, then, all right, get the square root of 3 times 5 plus 1. Is that equal to 4? Now just do it all. 3 times 5 is 15, plus 1 is 16. Square root of 16, is that equal to 4? 4 equals 4, and it checks. All right, so now we'll say x equals 5. All right, so we're okay there. Now let's do this next one. So we'll start here. Square root of 3x plus 1 equals negative 4. Now, I'm getting the square root of some number, and I'm getting a negative. Now, when we solve these equations, we're going to have to check. So let's see. Let's square both sides. So we'll get the square root of 3x plus 1 squared equals negative 4 squared. Okay, so far so good. This will give us 3x plus 1, right? When you square root, the radical comes off, equals 16. Well, it looks like what we just had here. So 3x equals 15, x equals 5, we think. Okay, but now you have to check it. You have to check. So let's say if x equals 5, then, okay, what do we get? So put that 5 right there, put it back into the original equation. So we'll get this. Square root 3 times 5 plus 1, okay, is that equal to negative 4? Well, this will give us the square root of 16. Is that equal to negative 4? Well, square root of 16 is 4, and 4 is not equal to negative 4. So x is not equal to 5, but so we have to toss it out, right? So toss out the 5. Well, that's all we had left. So all we can say now is that there is no solution to this equation. Question 3, let's square both sides. That's a good place to start, so it'll look like this. Square root of 4a minus 4 squared equals 4 squared. So on the left side, when we square the square root, that radical comes off, like we're unsquare rooting it, equals 16. Let's add 4. We'll get 4a is equal to 20. Divide. A is equal to 5. We think. All right, we need to check it. So we run a check, and we'll say if a equals 5, then here's what we get. Take that 5 and put it back into the original equation. It will look like this. 4 times 5 minus 4. Is that equal to 4? All right, now just do the left side all. 4 times 5 is 20. 20 minus 4 is 16. So we have square root of 16. Is that equal to 4? Well, 4 equals 4. It checks. So now we'll conclude that a is equal to 5. Question 4, let's start by isolating the radical. Get this radical by itself on that left side. So let's subtract 3. So if you subtract 3, we're going to have square root 6x plus 1 equals 8 minus 3 is the 5. Now we'll square both sides. All right, I squared the square root equals 5 squared. Square root, that radical is gone. 25. Now, subtract the 1. 6x is 24, so x we think is 4, but we need to check. We know we have to check it, so we will say if x is 4, then, all right, put that 4 right there, put that back into the original equation. We will get square root 6 times 4 plus 1, and then a plus 3. We're asking, is that equal to 8? Well, let's see. What do we have here? 6 times 4 is 24, plus 1 is 25. Square root 25 is 5. 5 plus 3, is that equal to 8? Yeah, 8 equals 8. So now we conclude that, sure enough, x is equal to 4. Question 5, well, let's see. We're supposed to solve for x at each one of these equations. So let's start with that top one. I'll start with this one here. 6x minus 2, and then I've got a plus 7 equals 3. All right, let's isolate that radical. Let's subtract. So we'll get the square root of 6x minus 2 equaling, now 3 minus 7, negative 4. Now, let's stop. We could keep going, but when I check, you will find out that it does not check, and here's why. This symbol right here, that square root sign, all right, that indicates the positive square root. Remember, all real numbers have two square roots, one positive, one negative. This one, when you put that symbol over it, you're indicating the positive number, the positive square root. So write down, this says that a positive number is equal to the negative number, impossible. All right, so right away, I know that there is no solution to this equation. Let's try the second one. Now the second one is going to give us this. Square root 6x minus 2, right, minus 7 equals negative 3. So we'll get square root of 6x minus 2. Now add the 7. Positive 7 plus 3 is 4. Okay, now you can see what's going to happen here. You square both sides. And you get 6x minus 2 equals 16. Add the 2, we'll get 6x equals 18. X equals 3, we think. But put that 3, right, we have to check it. So here's the check. If x equals 3, then, all right, put that 3 back into the original equation. So put it back in here. Put the 3 right there. So we will have this. Square root 6 times 3 minus 2, and then minus 7. Is that all equal to negative 3? Well, what do we have on the left side? 18 minus 2. All right, 18 minus 2 is 20. Square root of 20. Well, that's insane, right? 18 minus 2 is 16. All right, so let's try it again. So I really got a 16 here. So 16 minus 7, now is that equal to negative 3? Square root of 16 is 4. 4 minus 7 is negative 3. That equals negative 3, and this thing checks. So we can now conclude that x, sure enough, is 3. Well, here in question 6, we have a cube root. So instead of squaring both sides, let's cube both sides. How about if we write this? Quantity, cube root of 2x minus 1 cubed equals negative 3 cubed. Now, on the left side, you cube a cube root, and you just get that base, 2x minus 1 equals. Now, negative 3 cubed, negative 27, right? Negative 3 times negative 3, positive 9 times negative 3 again, negative 27. Let's add the 1. 2x equals now negative 27 plus 1, negative 26. Looks like x is equal to negative 13, we think. Now, I'm going to just claim that this is true, right? I'm going to claim it's true. And the reason I should check it, of course. But here's the thing. When you raise both sides of a radical to an, when you raise both sides of an equation to an even power, you have to check. If you raise it to an odd power, you should check, but you really don't have to. So I'm going to claim that x is negative 13. All right, and that finishes up our first part of homework set 22.